Okay, so in this video, we will solve this question valid parenthesis. So this is an easy type of question of stacks, and here we have given a string which contains a character, which contain many character. So it means it contains brackets. This it can be this small bracket and this closing small bracket, opening bracket, this type of curly braces and square brackets. Okay, and as input string is valid if open bracket must be closed by same type of bracket. So means if I'm opening my bracket like this, wait, let me show you. Then I should close my bracket like this only. I cannot do this. If I'm doing this, see this. I'm opening my bracket with the square bracket and I'm closing with a small bracket. So this is not valid. So if this condition happens, we have to return false, else we return true. So see this example, you will understand it clearly. So see, I'm opening with small bracket and I'm closing with a small bracket. So this is returning me true. See here, these two brackets are a pair of each other, so no problem. These two back brackets are pair of each other, no problem. These two brackets curly braces are pair of each other, no problem. So we are returning true. Now see this, here we are opening it with square bracket and we are closing it, we are opening it with round bracket and we are closing it with square bracket. So that's not valid here. We will return false here. And here as well, see this, we are opening with round brackets and we are inside them we have a pair of square brackets, so this is totally valid. And this one is not valid, you can see. So constraints are s dot length is 10 raised to power 4 from 1, and s consists only these three parentheses, these three pairs. So let me tell you this problem. Wait, let me remove this question because I will solve it in my next video. Okay, so yes. So whenever these type of question comes to you, always think about stack. Okay. So suppose we have a the pair of parentheses like this. These pair of parentheses, this, and this, and after that this. So I'm making my stack. Okay. Suppose this is my stack, and I will push my first element. If my bracket is opening, like here, this is an opening bracket, so I will push it into my stack like this. Okay, and this is also opening bracket. I will push it into this stack, and after that, see, this is a closing bracket, so I will not push it. Now I will pop the topmost element of my stack, which is this bracket, this square bracket, and I will check if this equals to, if this bracket is matching my s of I, this is my s of I, then no problem, remove it. So we are removing it. Now my stack is looking like this, only containing this bracket. Now my s of I is this. So again, I found a closing pair of bracket. I will pop it. I will check it. If this bracket is a pair of this bracket, then no problem. Else, uh, then no problem. Remove it. And now my stack will be empty. So at last, I will check if my stack dot length is empty. Nothing is in my stack. So I will return true. Okay. Else, now see another use case. Let me give you a pair of brackets like this. See, I'm closing it with this type of bracket. So here, first time my s of I will be this. So let me make my stack. So suppose this is my stack. Sorry, I do not have stylus, so please manage this handwriting. Okay, so first my s of I is this initially, and I will push because this is the opening pair of bracket. So I will push it into my stack. Again, this is our opening pair of bracket. Now s of I will be this thing. So I will again push it into my stack. Now see this. This is my closing pair. Now I got a closing pair. This is not a opening pair. So what I will check? I will check is this matching? Now I got a closing pair. So I will pop this out and I will check. This is my popped out element, and I will check if this is a pair of this. Yes, it is a pair of this. So I will remove it. Now my stack looks like this. Okay, and now I got a closing pair of bracket s of I. This is my s of I. So I will pop this out. Okay, and see, this is my popped out element, and I will check it with what? With this curly braces. Are these pair of each other? No, these are not pair of each other. They are not. So I will return false here. And suppose we only have a string which has uh, suppose my s is equals to this, a closing pair of bracket. So this time I will not, my stack will only be empty. This condition fails. No opening bracket, no filling of stack. So now what I will do? If my stack dot length is empty, suppose I popped something and it is undefined, I will return false. So see the code, you will understand it properly. So let stack is equals to this. Okay, in JavaScript we have stack array. In Java you can use a stack class. Suppose, see, the concept will remain same, but making of stack and variables will be different. So ignore that. In your language you can also do that. Uh, See the logic here, and okay, now I will do what? For wait, let I is equals to 0, and I will go up to s dot length, yes, and I plus plus, yes. So if my s of I is equals to what? If my s of I is a opening bracket, so this is closing, yes, this is a opening pair of bracket, and या फिर or like sorry, or my s of I is equals to uh, this, or s of I is equals to wait, sorry, not or, is equals to, I will tell you a modified version of this code. So this is a lengthy type of thing we are writing, this hard coding this. So uh, square brackets, and third type of bracket is this. If my s of I is this, I will push it into my stack dot push. Okay, stack dot push what? S of I, yes. So no problem. Else what I will do? I will pop out first element. See, I was popping out first element from here. Whenever I find a closing pair of brackets, suppose this is a closing pair, I will pop this element out. This is my topmost element. Sorry. Yes. So this is my topmost element. Let top is equals to, wait. Top is equals to what? Stack dot pop. And now I will check if uh, my topmost element is equals to, suppose it is equals to what? It is equals to this curly braces, and s of I is not equal to uh, my opening closing curly braces. See, top cannot be a closing, this should be open. Top will always be the opening braces of each type. Top can be this, top can be this, but top cannot be this, top cannot be this. Hope you can understand this. And see, uh, yes, so I'm copying it, and now I'm putting into a bracket, small bracket. So first condition is this: if top is this and s of I is not this, then return false. Or if top is a square bracket and s of I is not a square bracket, then return false. Or you can do one thing as well. We have another pair. If suppose top is equals to a small bracket and this is not a small bracket, then return false. Yes. So we have many ways to do the same program. Do the same program. Okay. I should make all of them in a bracket, right? That will be a good way and cleaner way. You won't find any error then. Yes, and yes. So I guess I have done everything right now. Till now, I'm doing everything right. Uh, If I found any of them, I will return what? False. Else, no problem. If this not happens, continue running loop, pop every element. Okay. And at last, I would like to return what? I will return stack dot length is equals to 0. If my stack dot length is 0, return that is completely okay. Your brackets are paired. And if it is not 0, and let me tell you the case where it will not be 0. Suppose my bracket is this, my s is this. So now s of I is, what will be the s of I? S of I will be this. See, my bracket, no, here it is not listed. Here this example. Suppose my s of I, this is s. So suppose my s is this. This is my s. Okay. Suppose this is my s. I'm telling in you a more uh, precise way. So suppose this is my s. So my s of I will be this bracket, square bracket. Okay, but here my condition is checking for what? Opening bracket. So this is not a opening bracket. So we'll fall into else condition. Now in else condition we will let top is equals to stack dot pop. So we will try. Initially our stack will be there in this question. Stack is empty, and you are trying to pop something from that stack. So this will give you an undefined condition. Yes, and so I should add this condition as well. If top is not defined, then also return false, else return true. Let me see, is it, yeah, it is working totally fine, and let me submit it. uh, Wait, yeah, my code is running perfectly fine, and yes, so yes, and let me see the time complexity of my code now. Let me guess it. So our stack could be length of n. Yes, it can be an n length stack. Yes, there can, you can found n number of pair from these three brackets. You can form that. So that's why my stack length is can be n. So we are using a space of that stack. So space complexity is O of n, and let me see what will be the time complexity. So we are running a loop up to stack dot length. So we'll go up to n, and we are checking each of the bracket. Okay, so O of n, both will be O of n. Yes, analyze complexity. Uh, O of n, yes. And space, is there any option we can analyze space complexity? Memory. What is this memory? Yes, space complexity, O of n. So thank you so much.